Hello Gen Chem friends, welcome to my first little vignette on Chapter 2. And in this section of the course we're going to focus on really the building blocks of what chemists deal with, specifically elements and compounds. Now we at least in the course, we introduced those two terms when talking about how to classify matter. We said if we had a pure substance, if we could separate it into simpler substances, then that was a compound. Things that cannot be separated into simpler substances, those are elements. And those are those beautiful things on the periodic table that we will talk a lot more about later on in this chapter and throughout the course. So since elements really are the building blocks for compounds, let's go ahead and focus first on elements. So what exactly makes up an element? Well, hopefully you remember either from intro chem or physical science class that elements, their building blocks are atoms. And so this cartoon up here, which I know is a little fuzzy, but I like this cartoon because it illustrates the evolution of how scientists thought of the atom. We'll talk more in detail, particularly about the scientists and models from Thomson down through to the quantum mechanical cloud model. What you should take home from this slide is that elements are made of atoms and that the atom is the smallest particle of an element that still has properties of that element. If I have atoms for helium, all of those atoms are identical to each other, but distinctly different than atoms that make up another element like magnesium or hydrogen. Atoms can be actually further subdivided into 3 subatomic particles, which you need to know those names of, and we'll talk about this slide now. So atoms, their building blocks, for all intents and purposes of this course, are protons, neutrons, and electrons. Protons and neutrons for an atom are located in the center or the core of the atom, which we call the nucleus. The electrons are outside of the atom, just kind of hanging around, circulating outside of the nucleus. Now later in the course, when we talk about the quantum mechanical model, we'll talk in more detail as to where specifically an electron is in an atom. But for right now, you should just know the general location of protons and neutrons for an atom, which is the nucleus, the center. Know that electrons are hanging around outside of the nucleus, surrounding the, orbiting the nucleus. And while you don't need to know the specific masses of each subatomic particle, you should be able to know or remember that protons and neutrons are a heck of a lot heavier in atomic mass units than the electron. So you should know that the majority of the mass of an atom is in its nucleus. And you should also know the charges that are associated with those subatomic particles. Neutrons have no charge, while protons are positively charged and electrons are negatively charged. So that's information you should take home from this slide, and it's summarized also in this slide, but there's another very important point I want to make here before I stop, and that's with regards to electrons. The electron is really going to be our favorite subatomic particle, if we had to name one, because when we talk about chemical reactions, it turns out that chemical reactions and making new molecules is all about the loss, gain, or sharing of electrons, that subatomic particle that's hanging around outside of the nucleus. So it's because chemical equations or chemical reactions deal with electrons, many times atoms will have a charge associated with them. Something that is a positively charged, like a hydrogen atom that has a positive charge, that means it has lost an electron, something that is negatively charged. Species that are anions are those that have a certain number more of electrons than protons. So take-home message from this slide before I stop here is that it is through the loss or gain of electrons, that makes an atom either a cation, positively charged, or an anion, negatively charged. You never want to muck around with the number of protons and neutrons for an atom, because if you do that, then you've fundamentally changed the identity of that atom, okay? So charged species, cations and anions, are always made by changing numbers of electrons. So in the next videos, we're going to talk about, well, how do I determine how many protons, neutrons, and electrons a particular element has? We will deal with that in the next 2 videos.